Essential truth number 3. AI's real capabilities are narrower than the headlines suggest. The hype versus reality. AI's true limits. Understanding AI's actual abilities. When AlphaGo defeated Lee Sedol in March 2016, headlines screamed that machines had surpassed human intelligence. They hadn't. Google's AI had mastered one extraordinarily complex game. Nothing more, nothing less. Ask that same system to identify a cat in a photograph, and it would fail completely. Gibbs, 2016. This distinction reveals what AI actually does well versus what we imagine it can do. Modern AI excels at narrow, specific tasks, recognizing patterns in massive data sets, predicting credit card fraud, recommending movies based on viewing history, translating text between languages. These capabilities are genuinely impressive. They're also profoundly limited in ways headlines rarely mention. Consider the difference between pattern recognition and genuine understanding. When an AI analyzes thousands of medical scans to identify potential tumors, it's detecting visual patterns it has learned to associate with cancer. It doesn't comprehend what cancer is, why it develops, or what a diagnosis means to the person receiving it. The system processes data without context, insight, or comprehension. A radiologist looking at the same scan brings decades of medical knowledge, awareness of the patient's history, and the ability to notice anomalies that fall outside standard patterns. The AI can assist that radiologist, sometimes quite effectively, but it cannot replace the thinking that happens behind those human eyes. Most AI systems today operate like highly specialized tools rather than flexible minds. They perform specific functions within carefully defined boundaries by finding statistical correlations in training data. When you ask your phone's assistant about tomorrow's weather, it's not reasoning about atmospheric conditions. It's matching your words to weather data and responding with programmed patterns. This narrowness isn't a temporary limitation waiting to be solved next year. The gap between processing information and understanding meaning represents one of the fundamental challenges in AI development. Recognizing this gap doesn't diminish AI's usefulness. It clarifies where that usefulness actually lies and where human judgment remains irreplaceable. Debunking the myth of omnipotent AI. Let's start with something you've probably seen more than once. The headlines that scream about AI making independent decisions or learning on its own. These stories sound dramatic, even frightening. You might read that an AI system has begun to think for itself, or that machines now possess the ability to develop their own moral judgments. It's the kind of language that sticks with you, especially when it's repeated across news outlets and social media. The truth is far less sensational. AI doesn't independently learn the way you or I do. When we say an AI learns, we're really describing a process where it identifies patterns in data that humans have carefully selected, cleaned, and fed into the system. The AI doesn't wake up one morning curious about philosophy or ethics. It processes information according to mathematical rules, programmed by people, adjusting its calculations to improve accuracy on specific tasks. So, why does the myth persist? Media outlets know that stories about autonomous, thinking machines generate clicks and shares. Fear and fascination drive engagement, and nuanced explanations about statistical models and training datasets don't have the same appeal. This creates a cycle where exaggerated claims become the norm, while the more mundane reality gets buried. When you encounter claims about AI's supposed moral reasoning or self-directed learning, pause and ask, who programmed this system? What data was it trained on? What specific task is it actually performing? These questions cut through the hype. They remind you that behind every AI system are human designers making deliberate choices about what the technology should and shouldn't do. Understanding this gap between headlines and reality doesn't just reduce anxiety, it empowers you to evaluate AI claims with confidence and clarity. Human oversight and AI limitations. Why does any of this matter to you? Because the stakes are deeply personal. When AI systems start making decisions that affect your healthcare, your financial security, or even your daily routines, you deserve to know what those systems can and cannot do. The gap between AI's actual capabilities and what you've been told has real consequences for trust, autonomy, and your sense of control over the technology shaping your world. Consider what happens when AI is deployed in medical settings. Research shows that patient trust remains one of the biggest barriers to AI adoption in healthcare. Firth et al., 2026. Nong and Platt, 2025. Arizinow.com, 2026. Nong and Platt, 2025. People express legitimate skepticism about letting algorithms make decisions about their treatment, especially for serious or complex conditions. They worry that AI can't understand their individual circumstances, their personal history, or the nuanced factors that make their situation unique. More importantly, they miss the empathetic connection they value from human clinicians, the ability to be heard, understood, and treated as more than a collection of data points. These concerns aren't irrational. They reflect a fundamental truth about AI's limitations. AI excels at pattern recognition within massive datasets. It can spot correlations that human eyes might miss, but it cannot make ethical judgments, cannot weigh competing values the way you do when facing difficult decisions, and cannot provide the compassion that defines meaningful human interaction. When a doctor explains a diagnosis, they're not just conveying information, they're reading your reactions, adjusting their approach based on your emotional state, and drawing on years of experience with the unmeasurable complexities of human suffering. No algorithm can replicate that. This reality should reassure you. Human oversight isn't just helpful in AI deployment, it's absolutely essential. The systems work best when they augment human judgment rather than replace it. Your intuition, your ethical reasoning, your capacity for empathy, these remain irreplaceable. Understanding this distinction helps you approach AI with appropriate expectations rather than fear or uncritical acceptance. You can ask better questions about how AI tools are being used in areas that affect your life, and you can insist on maintaining meaningful human control where it matters most. The myth of autonomous AI: why human oversight remains crucial. Human oversight in AI development. Human oversight operates not as an optional safety layer, but as the foundational architecture of every functional AI system. The technology cannot exist without constant human decisions guiding its development, deployment, and operation. Consider what happened at Amazon. In 2018, the company built an AI recruiting tool designed to screen resumes and identify promising candidates. Engineers trained it on a decade of hiring data, expecting the system to recognize patterns that predicted successful employees. Instead, the AI taught itself to downgrade resumes containing the word women's, as in women's chess club captain, and systematically penalized graduates from all women's colleges. Amazon's historical hiring data reflected a male-dominated tech industry, and the AI simply learned to replicate that bias. Human oversight caught this before the system affected real applicants, and Amazon reportedly scrapped the project entirely by 2017, with the issues becoming public in 2018. Daston, 2018. This wasn't a malfunction. The AI performed exactly as designed. It found patterns in the data provided. What it lacked was the human capacity to recognize that replicating historical patterns would perpetuate discrimination. No algorithm can independently determine whether a statistical correlation represents something worth preserving or something worth correcting. The financial industry provides another compelling case. Banks now use AI extensively for loan approval decisions, analyzing thousands of data points to assess creditworthiness. In 2019, New York's Department of Financial Services launched an investigation into Goldman Sachs, the issuer of the Apple Card, after multiple complaints that its credit algorithm was offering men significantly higher credit limits than women with identical financial profiles. Davis and Serene, 2019. The problem wasn't intentional discrimination programmed into the system. It was that the AI identified gender-correlated patterns in historical lending data and amplified them. Human intervention ultimately identified and prompted correction of the bias that the algorithm could never recognize on its own. Healthcare demonstrates why oversight extends beyond fixing problems to enabling appropriate use. IBM invested heavily in developing Watson for oncology, training the AI on medical literature and case studies to recommend cancer treatments. Yet, oncologists at institutions like MD Anderson Cancer Center found the system suggesting treatments that contradicted standard care practices or ignored crucial patient-specific factors like age and other medical conditions. Ross, 2018. The AI excelled at processing published research, but often failed to weigh the nuanced judgment calls that define good medical decision-making. Hospitals didn't abandon the technology entirely. Rather, they reframed it as a research tool to supplement physician expertise rather than guide treatment directly, highlighting the need for careful human integration. These examples share a common thread. AI systems inherit human values, biases, and limitations from their training data and design choices. They cannot question whether their outputs serve human well-being or perpetuate harm. Oversight operates at multiple stages. Before deployment, human teams must decide what problem the AI should solve, what data to use for training, and what outcomes to optimize. During operation, people monitor performance, identify unintended consequences, and adjust parameters. After implementation, humans interpret results within broader contexts the AI cannot access. This reality contradicts the narrative of AI as an autonomous force beyond human control. Every algorithm reflects choices made by specific people working within particular organizations, subject to oversight, regulation, and accountability. Risks of neglecting oversight. The absence of meaningful human oversight doesn't just create risk, it can turn AI systems into instruments of harm. In 2018, an Uber self-driving car struck and killed pedestrian Elaine Hertzberg in Tempe, Arizona, marking the first known pedestrian fatality involving an autonomous vehicle. National Transportation Safety Board, 2019. The tragedy wasn't simply a technological failure, it was a failure of human responsibility. The National Transportation Safety Board investigation revealed a cascade of decisions that prioritized efficiency over safety. Uber had disabled Volvo's standard collision avoidance system, City Safety, to prevent conflicts with its own software, eliminating a critical safety redundancy. National Transportation Safety Board, 2018. The company then relied on a single safety driver who, investigators discovered, was streaming a television show on her phone at the moment of impact. National Transportation Safety Board, 2019. Tempe Police Department, 2018. The AI itself detected Hertzberg 6 seconds before the collision, ample time to prevent the tragedy. National Transportation Safety Board, 2018. But the system struggled to classify what it was seeing, vacillating between identifying her as an unknown object, then a vehicle, then a bicycle. Uber's engineers had programmed the AI to minimize false positives, requiring high confidence before initiating emergency braking. This design choice reflected a trade-off: reduce unnecessary stops to make rides smoother and more marketable. National Transportation Safety Board, 2019. But without adequate human oversight to validate that trade-off in real-world conditions, the system hesitated when decisiveness was required. This case illustrates a fundamental truth. AI systems operate within the boundaries humans establish. When those boundaries are poorly designed, inadequately tested, or carelessly monitored, the technology becomes dangerous. The Hertzberg tragedy wasn't caused by AI going rogue. It resulted from human decisions to cut corners, ignore warning signs, and prioritize commercial goals over safety protocols. Similar patterns emerge across industries. Automated hiring systems have rejected qualified candidates based on biased training data. Algorithmic trading programs have triggered market crashes within seconds. Each incident traces back to insufficient human engagement. Developers who didn't anticipate edge cases, managers who didn't require rigorous testing, or operators who trusted the system beyond its actual capabilities. Continuous human oversight isn't optional. It's the essential safeguard that ensures AI serves humanity rather than endangering it. This means establishing clear accountability structures, maintaining meaningful human involvement in critical decisions, and building systems with transparency that allows for ongoing evaluation and correction. When we maintain this engagement, AI becomes what it should be, a powerful tool that extends human capability while remaining firmly under human control. Then understanding AI's current and future potential. Current AI capabilities. Start with something simple, your email spam filter. This week, check your inbox, whether it's Gmail, Outlook, or Yahoo, and notice which messages make it through and which get caught. Every major email service uses machine learning to make these decisions, scanning patterns in billions of messages to separate legitimate correspondence from junk. When you find a real email incorrectly flagged as spam, mark it. You're not just fixing an error, you're teaching the system, demonstrating the human-AI collaboration at the heart of how this technology actually works. Now look at your bank or credit card app. Most financial institutions use AI to flag unusual transactions automatically. Review the alerts you've received over the past few months. Did the system correctly identify suspicious activity? Or did it flag your own legitimate purchases, maybe when you traveled to a new city or tried a different grocery store? This simple exercise reveals AI's genuine strength in pattern recognition alongside its fundamental limitation. It knows your spending habits, but cannot understand context the way you do. Next time you visit your doctor, ask a direct question. Do you use any AI-assisted tools in diagnosis or treatment planning? You'll likely discover algorithms helping read medical images. Systems like the one developed by Google Health, published in Nature Medicine in 2021, which assists in detecting pathologies, including fractures from chest x-rays. Then ask the critical follow-up. How do you verify the AI's recommendations? Their answer will illuminate the oversight structures protecting you, the human judgment that remains essential even as technology assists. Try using a customer service chatbot this week, but approach it differently, as an observer rather than just a frustrated customer. Notice exactly where it succeeds, handling straightforward requests, accessing your account information, providing business hours. Then, identify precisely where it fails and transfers you to a human representative. You'll see the narrow capability we've been discussing throughout this chapter. These aren't abstract exercises. They're observations of AI already shaping your daily experience, helping you see both its genuine utility and its fundamental dependence on human judgment. Future AI developments. You don't need to become an expert in AI to engage with it wisely. That's an important truth worth sitting with, especially if you felt overwhelmed by technical jargon or intimidated by how quickly this field evolves. The goal isn't mastery, it's informed participation in decisions that affect your life. Progress looks different for everyone. For some, it means asking your bank's representative about fraud detection algorithms during your next visit. For others, it's reading one article per month from a mainstream publication like The Wall Street Journal or The Atlantic that covers AI developments without requiring a computer science degree to understand. You might simply start conversations with family members about how they encounter AI in navigation apps, photo organization, or streaming recommendations. The most common obstacle isn't complexity, it's the assumption that you've already fallen too far behind to catch up. Many individuals, regardless of their technical background, initially assume machine learning is beyond their grasp. However, they often demonstrate profound insight once they realize the conversation centers on human choices about technology rather than complex mathematics. You already possess the critical thinking skills required. When you question whether your medical diagnosis should rely entirely on an algorithm or wonder if automated hiring systems might miss qualified candidates, you're engaging the exact reasoning this moment demands. Another barrier, perfectionism. You won't understand every development, and that's acceptable. Researchers at Stanford and MIT don't fully predict where this technology leads either. What matters is maintaining curiosity over certainty. Asking questions when AI systems affect decisions about your healthcare finances, or privacy. You'll encounter articles that lose you in technical details, or news coverage that sensationalizes rather than explains. When that happens, step back to basics. Who built this system? What problem does it solve? And who oversees its decisions? Those three questions unlock understanding far more effectively than attempting to decode algorithmic mechanics. Your perspective matters precisely because you bring lived experience that technologists often lack. Implications for society. AI's capabilities remain narrower than the headlines would have you believe, but that doesn't diminish its real-world impact. Throughout this chapter, we've examined the gap between perception and reality, the difference between systems that recognize patterns within constrained domains and the science fiction notion of machines that truly think. Narrow AI dominates our current landscape. Algorithms excel at specific tasks like image classification, language translation, or recommendation generation. Yet they fundamentally lack the flexible reasoning humans apply effortlessly across contexts. This distinction carries profound societal implications. When companies deploy AI for hiring decisions, the technology doesn't evaluate candidates with human judgment. It identifies statistical patterns in historical data, often perpetuating existing biases unless humans actively intervene. A notable example is Amazon's experimental recruiting tool, which was scrapped after demonstrating bias against women, largely due to being trained on historical data from a male-dominated tech industry. Similarly, when healthcare systems implement diagnostic algorithms, these tools process vast medical literature faster than any physician could. Yet they cannot weigh the nuanced, patient-specific factors that define compassionate care. Ross and Herman, 2019. IBM Watson Health faced significant challenges in clinical deployment, including generating unsafe and incorrect treatment recommendations for cancer patients, highlighting the need for extensive human oversight and real-world validation. The economic consequences ripple outward. Jobs transform rather than simply disappear, creating demand for workers who can oversee, interpret, and correct AI outputs, while rendering obsolete roles based purely on routine pattern matching. Workforce changes demand our attention, not our panic. History shows that technological shifts create turbulence alongside opportunity. The question isn't whether AI will reshape employment, it already has, but whether we implement it responsibly, with retraining programs, transparent accountability structures, and genuine human oversight at every critical juncture. Ethical considerations emerge at each deployment point. Who bears responsibility when algorithms make consequential errors? How do we ensure marginalized communities aren't disproportionately harmed? And what prevents commercial priorities from overriding safety protocols? These aren't abstract philosophical puzzles. They're urgent, practical questions requiring your engagement. AI shapes society through countless small decisions made by developers, managers, and policymakers. Decisions that benefit enormously from diverse perspectives, especially from those who've witnessed previous technological transformations and understand their unintended consequences. Your skepticism, your insistence on clarity, your refusal to accept the algorithm decided as sufficient explanation, these represent exactly the guardrails this technology needs. We've established that AI remains fundamentally limited, profoundly dependent on human guidance, and far from the autonomous intelligence popular culture imagines. What comes next examines how you move forward with this knowledge, translating understanding into confident participation in an AI-influenced world.